Today's lesson is on 3-4 implicit differentiation. So all the derivatives we've done up to this point are known as explicit equations. That means we've known exactly what y was because it's in the form y equals. Here are your examples right there. Y equals x squared, y equals x over x minus 1, y equals the square root of 2x plus 1. So all of these are explicitly expressed y in terms of x. So now we're going to be working with equations that are implicit equations, where the thing is now x isn't all alone. For example, we have an x squared plus a y squared equals 1, or xy plus y squared equals 3. Last example, xy equals 1. So all of these are known as implicit equations. So in order to take the derivative of them, we need to know a method of how to do this. So as long as you follow these steps, the derivative is pretty straightforward. One thing we need to talk about before we take the derivative, just with the example of y equals x squared, one way we've written it, we've done y prime equals 2x, where we're going to do the other notation that before we could write dy dx equals 2x. So we've been doing this method all along, you just haven't noticed it. But we're going to focus on this method right here, because it's very important when we do implicit differentiation. It helps us do one variable, because remember, this is the derivative of y with respect to x. So think of y. What would the derivative of y be? Well, we know it would be 1, but to let us know we took the derivative of who, we write dy. So dy equals, now take the derivative of x squared. Well, the derivative of x squared is 2x, but once again, who did we take the derivative of? We took the derivative of x, so we write dx. The next move is what we've been doing, but we just haven't been writing it down, is we divide both sides of the equations by dx. So what happens to dx over dx? Well, that's just 1, and that's why we've always ended up with the dy over dx, because that move is very important when we do implicit differentiation. Just keep your dy's and your dx's with your dx's as well. So now that you kind of understand that, let's explain these steps right here. So number 1, differentiate both sides with respect to x. That is saying keep your dy's, keep your dx's, okay? Then, see, that's why this kind of simplifies it down a little, and our book will read a little different. Then divide everything by dx. So each term gets divided by dx. Then you know your dx's over dx's will cancel out. Then that will take you to step 2. You want to get everything that has a dy dx all on one side. So it's just through your algebra, adding and subtracting, isolating it. Step 3, then we need to factor out dy dx. And then we solve for dy dx, which happens through division. So I know that doesn't seem like it makes a lot of sense. You'll see it each step as we go through our next examples. So remember, if you get lost, look at your steps. So we're just going to do a warm-up here. What's the derivative of y? dy equals dx. Practice that division. Divide by dx, divide by dx. So I would have dy dx equals 1. Okay, I could do the same thing there. Here, this is practicing your chain rule that you just learned. The chain rule is there also on those two examples. dy equals 2, leave the inside alone, times the power stays, goes down to 1 because we subtract 1, times it by the derivative of the inside, f prime of x, dx, divide by our dx, takes us right there. So some of you'll get to the point where you know your dx's are going to cancel, so you don't need to write them every time, and that's okay. So let's look at this last example. Here we have dx equals 2y dy. So the next move is to divide each side by dx. And of course, the way I do it, you always want to put the dx under the dy. So dx over dx is just 1. Now our goal is to solve for dy dx. So we need to move to y. How do we move to y? Well, what is it doing to dy dx? It's timesing, so therefore we need to divide both sides by 2y. So now the derivative is 1 over 2y. So you're going to notice now with our derivatives, we're going to have x's and y's involved. And that's okay, so don't wig out. Okay, now let's look at our examples where they're starting to look quite messy. We want to find y prime, which means find dy dx, so let's start taking the derivative. What's the derivative of x squared? 2x dx. And I'm going to do the dx's right now until you get a little more comfortable with this. Take the derivative of this term. Now we're dealing with y's. I still apply the power rule. Negative 6y squared, but I need to write dy because I took the derivative of y. Now we're on this term, plus 3 with respect to which variable? X, so dx equals the derivative of any constant is 0. So now divide each thing by a dx. Well, 0 over anything is 0, so that's why I'm just going to leave 0 right there. My dx's just become 1, and if you notice, this is what I'm trying to solve for, so I'm going to move it to the other side. So I move it over there, and I'll have 6y squared dy dx equals 2x plus 3. So our last move, we need to solve for dy dx, which means we need to move the 6y squared. How do we move 6y squared? Well, we divide. So there is our derivative. 2x plus 3 over 6y squared. And I know a lot of you are thinking, that just looks a whole lot worse than what we started with, but that's okay. It represents the slope of that equation at any given point. Okay, let's look at the next question we have. It says, find the slope of the line tangent to and normal to the graph of that function. So remember, the tangent line is the derivative. The normal line is just perpendicular to the derivative. And we just need to find the slope. We didn't have to write an equation. So we need to solve for dy dx. So we take the derivative. The derivative of x squared is 2x dx plus 8y dy equals 0. Step 2, divide by dx. Once again, the 0 thing is going to go away. This time, so now we're on step 3, get dy dx all alone. So I have 8y dy dx equals negative 2x. And the last move, I don't have any factoring to do here because I only have one dy dx. So I'm just left with the last step, which is to divide. So dy dx equals negative x over 4y. but they want the actual slope. So we need to plug in the point. X is, I'm going to come over here, negative 3 over y is 2, 8. So there's the tangent line. The normal slope would then be the negative reciprocal, which would be 8/3. So there's the tangent slope. There's the normal slope. Okay, our last two examples we have, we're going to find dy dx and then evaluate the point. So if you notice that this one just looks messy, and you're going to have to be quite careful right there. You're going to have to do the product rule. And the thing that gets students every time is that negative 2. And you can either pull it out and then bracket and do the product rule of x and y, or you can remember to FOIL it in. I'm going to do the brackets, so you'll have to FOIL it in later, because I think that way's best, because I have too many students who always lose that constant on the second term. Okay, so here we go. The derivative of x cubed is 3x squared. And hopefully maybe by now I can drop the dx's. I'm not going to write dx because I know I'm going to divide by dx, which is just going to be 1. Okay? Now I'm going to do the product rule. But I'm going to go negative 2, bracket or parenthesis, whatever. Take the derivative of the first. What's the derivative of x? Well, that's going to be dx over dx, which is just 1. I leave y alone. Plus, now leave x alone. Take the derivative of y. Well, the derivative of y is 1, but we must write dy dx. Now I'm done with the product rule, so I close my parentheses. Once again, let me explain that. Right here we took the derivative of x, which is 1, which would give me dx over dx, so I'm not going to write it because it's going to cancel. Y stays. I leave x. Take the derivative of y, which is 1, but we took the derivative of y, so I got to write dy, and then we divide by dx. That stays. It doesn't cancel. Plus, now we're right there. The derivative of y cubed is 3y squared dy dx equals, take the derivative of the last term, 5, take the derivative of x, which is the 5, and gives me dx over dx, which is 1. So now you have to remember to distribute in that negative 2. So 3x squared minus 2y minus 2x dy dx plus 3y squared dy dx equals 5. Now we want to keep everything with the dy dx on the same side and move everything else to the other. So these two are going to go to the other side. So that becomes minus 3x squared plus 2y. I have moved them. So now this is the new step that we didn't practice before. I want to solve for dy dx. How do I get dy dx alone? Well, this is factoring. Why we learn to factor is because it gets out that single term. So dy dx, parenthesis, if I factor dy dx from negative 2x dy dx, that leaves me negative 2x. If I factor dy dx from that term, I'm left with 3y squared. And once again, if I was to FOIL that in, I need to get that whole thing back, and you can see I do. Equals, I still have that on that side. Okay, our final move. How do we solve for dy dx? Well, this is timesing, so my last move is to divide. And divide this side. Negative 2x plus 3y squared. So there is the derivative. Now it says evaluate it at the point 1, 2. Sorry about that long pause. I dropped my mic and lost the battery. So, okay, the last move now is to evaluate plugging in 1, 2. So I'm going to come up here. We have 5. Plug in 1, 1 squared. That stays minus 3. 2 times 2, that's 4. Over, that's going to be negative 2. 2 squared is 4. Plus 12. So on the bottom, I have 10. 9 minus 3 is 6. 6 over 10 can simplify down to 3/5. So that would be the slope at the point 1, 2 is 3/5. Okay, so right now for your extra credit, tomorrow you need to draw on just a tiny piece of paper, a star, and set it on my desk. If you do that, you will get extra credit. Okay, we're going to end with our last example, number 4. We're going to take the derivative. Oh, this one's the second derivative, y double prime. So I'm going to come over here because it's going to take a lot of room. The derivative of x squared is 2x dx plus 2y dy dx equals 0. Solve for dy dx, which means I need to isolate 2y dy dx equals negative 2x. Last move, divide. That's 1. And yes, you can simplify that just to negative x over y. That is my first derivative. Now we want to do this second derivative. And you notice you're going to have to do the quotient rule here. So low, we leave y alone. D high, negative 1, which is dx over dx, which I don't need to write, minus high, d low, what's the derivative of y? That will be dy dx all over low squared. Well, that looks okay, but I don't like having this dy dx in there. Well, keep in mind, don't we know what dy dx is? We just solved for that at the very beginning. So now you're going to sub in. So negative y plus x times negative x over y all over y squared. Now we're going to get into algebra just to clean this up. So we're going to focus on that numerator, negative y minus x squared over y squared. So up top, we need a common denominator, which is going to be y. So I times this by y, which makes that a squared. Then I'm going to flip that one up, because 1 over y squared, we want that to cancel. And I have, coming over here, negative y squared minus x squared all over y cubed. And another final move you can do, we could factor out a negative of this. Like, you wouldn't have to go to this point, but sometimes they do. So I pull out a negative, and I get y squared plus x squared all over y cubed. Well, y squared plus x squared, we know what that is. That's 3. So now we know that the second derivative is really negative 3 over y cubed. I know that was a lot of substitution going on there. Review that one, and we'll do some more examples like that. And that is the end of 3-4.